गुड मॉर्निंग डियर फ्रेंड्स, नमस्कार मित्रों। अब तक पिछले कुछ वीडियो लेक्चर्स आप तक पहुंचाने की हमने कोशिश की है। निश्चित रूप से उम्मीद करता हूं कि ये सब आपके लिए फ़ायदेमंद साबित हो और आप सब लोग इनका पूरा उपयोग इस लॉकडाउन पीरियड में करें। पिछले वीडियो में हमने टोटल इंटर रिफ्लेक्शन और क्रिटिकल एंगल के बारे में समझा था। आज के इस वीडियो लेक्चर में मैं आपको टोटल इंटरनल रिफ्लेक्शन के एप्लीकेशंस के बारे में बताऊंगा। इन दिस लेक्चर यू विल लर्न अबाउट द एप्लीकेशंस ऑफ total internal reflection. I hope and understand that these sessions have been fruitful and useful for you. Keep watching, keep learning. So, dear students, in this lesson we will talk about the applications of total internal reflection. The first application is to deviate image by 90 degree. For the purpose, we use right angled isosceles prism. Let us consider this ABC as right angled isosceles prism. In this, AB is equal to AC and this angle B is 90 degree. Let we have this object PQ taking two rays originated from these two ends of this object. These two rays are normal to the surface AB, so they go straight without any deviation, because the ray which is normal to the surface always goes straight. When these two rays incident on the side AC, then these two rays suffer total internal reflection. The reason behind is for the glass, critical angle is in the range of 41 to 43 degree, and here you can see these two angles are angles of incidence for the two rays 1 and 2, and this is ray 1 and this is ray 2. So these two rays will undergo total internal reflection and they will be total internally refracted with the angle 90 degree, like this. So we get the image of this object PQ here, and this side is P dash and this side is Q dash. If you consider the angle between these two, it's very clear. The angle between PQ and P dash Q dash is 90 degree. So in that way we can deviate image by 90 degree. So PQ is object and P dash Q dash is image. If you place object parallel to any of the two perpendicular sides which are equal also, you will get the same result. If you place object here, then P dash Q dash would be object and PQ would be image. If you place object here, then P dash Q dash is image. But in both the cases, the image will be deviated by 90 degree. This is one of the use of right angled isosceles prism. With the help of same prism, we can deviate image by 180 degree also. So the second application is to deviate image by 180 degree. For the purpose this time, we will use the third side of right angled isosceles prism. These two sides are as it is, we had taken in previous case. And the same we will do here also. But this time we will place object PQ parallel to the third side, which is AC here. So let the object is placed here, taking into consideration again two rays which are originated from point P and Q. When these two rays incident on the side AB, then they will be total internally reflected by the same logic. Now these two rays are incidenting on side BC in the same manner, so they will suffer total internal reflection once again. So in that way, we get the image of object PQ as P dash Q dash. It's very clear that these two are making angle 180 degree with each other. So PQ is object here also, and P dash Q dash is image here also. The angle between these two is how much? 180 degree. So this is another way to use right angle isosceles prism to deviate image by 180 degree. The third and very interesting application of total internal reflection is optical fiber cable. This is the cable used in present communication system. In short, we call it as OFC. The very important role of optical communication of this optical fiber cable in optical communication is It provides a medium for the propagation of optical signal. It means we use this cable as a channel. This cable is in the category of optical fiber cable. It has two regions. One is innermost one, known as core of this cable, and another one is cladding. It is the outer region of this cable. The optical signal which is to be transmitted through this optical cable is allowed to incident on the interface of core to cladding. The refractive index of core is mu2 and refractive index of cladding is mu1, such that mu2 is greater than mu1. Since the ray is entering from denser to rarer medium, so first condition is satisfied for TIR. The value of angle of incidence is taken such that it undergoes total internal reflection and it incidents on the opposite face. Again, it undergoes total internal reflection, and in that way it progresses through the optical fiber cable, and finally it leaves the OFC. So this ray is incident ray, or you can say it is input signal, and this one is emergent. This you can call as output. So this optical fiber cable is a very important part in electronic communication nowadays. Whatever signal we transmit, that first is converted into message signal, then it is converted into optical signal, and that optical signal is transmitted through the optical fiber cable to the desired end. Though in this mode the efficiency is 100%, the meaning of efficiency is the strength of signal, input signal and output signal are same. It means there is no loss, even though marginally if we consider losses due to unknown reasons, the efficiency in this mode is considered to be 95%. So these are the major applications of total internal reflection. I hope you understood the things properly at your own way. In the next lesson we will discuss few more things. Keep watching, keep learning and enjoy learning. Thank you very much.